Hi friends, this is Audi1 and you're watching part 2 of the video series on SQL injections. Well, for the installation of the test bed, you can refer to part 1 of this video series. Link is mentioned in the description of this video. Let's start. In order to test an application, any kind of application, first and foremost, we need to enumerate and understand the working of that application. Try to understand and find the entry points, meaning all places where a user can interact with the application by providing some input. Let's start with lesson 1. As you can see, it mentions please input ID as parameter with a numeric value. I have explicitly added some positions and pointers in pages to help along. So let's do that. So we provided a numeric value 1 to the parameter ID, and we see a username dump and a password dump on screen. Let's change this 1 to 2, 3, 4, 5. So we see that when we are iterating the ID parameter with values ID equals 1, ID equals 2, ID equals 3, 4, 5, we see some specific output on screen. So now comes the time that we need to visualize. We need to visualize about what could be the backend, or how could the backend be working, the SQL query at the backend. If we go back and try again or think again, we are providing an ID with parameter something, and we see a login name and a password on screen. So just building up a pseudo query, it would be like select login underscore name comma password from table where ID equals R provided input. Let's copy this 2 or 3 times. So let's say we provide ID 1, we provide ID 2, and we provide ID 3. So when we are providing a different ID, we are getting a different output on the screen. So this is the basic enumeration part for the application. Now it's time to have some fun. As we see, the developer of this page assumed that we are going to put some kind of an integer value or some kind of a numeric value into the field. What if somebody thinks outside the box and tries to put something else? But why would someone do that? Just in order to have some fun. Technically, our objective is to break the query. Our objective is to somehow damage the application and try to see what kind of response do we get from the database. Let's do something. Let's try to put a string here. Okay, nothing special happens here. We don't see the default username and password, just blank, but everything remains intact. Let me try some alphanumeric. Again the same thing. Let's try some big integer. Again the same thing. So we tried strings, we tried alphanumeric strings, we tried long integers. So in all of these cases we don't get any output. Let's try some special characters as well. Okay, nothing changes. Let's try one more, the single quotes, and we get an error. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL version from right syntax to use near something. Let's copy this part and let's paste it in the notepad. I'm not concerned about the initial things, so let's just be focused on this. If you see, we are able to successfully break the query. Well, this process of sending stupid, crappy, weird input to the application with the focus and the mindset to break it is called fuzzing. And mind it, it is very trivial for a successful exploitation. Coming back to the application, now to have more understanding about the error, we just need to interpret and understand this error. We copied this. If you see here, it looks like there are two quotes, double quotes surrounding the one, but actually they are not two quotes or double quotes, but they are two single quotes. And as I am spacing them out, you see that one is being encapsulated by the two single quotes. The first quote and this one is for the complete string. So let's remove that part. So you see clearly the input that we provided, one and a single quote. Logically thinking, we can see that we had one on the left, one on the right, and we added another one, so it makes it an odd pair, thereby breaking the query. Let's try to confirm this again, that what we have thought of is correct. So this time, instead of giving a quotes, let's try to use an escape character for MySQL, which by default is a backslash. Now if you see, one and a slash, and there is a single quote after that. Let's copy this part again. so we are not bothered about the last part. So as you can see, on line number 9 we escaped the right side quote by providing a slash in front of it, a backslash, thereby causing the error, because effectively there's only one quote remaining, that's on the left side. This is a very good trick to understand how the developer has encapsulated or enclosed his variables. So if we go back to our first query that we enumerated, we can simply say that the developer put a quotes around the input, and these quotes are not visible to us, and whatever input we provide is always encapsulated inside these quotes. Now, as we have broken this query, it's time to fix it. Fix it without modifying what we have actually inserted to break the query. So in our example, we had used one apostrophe to break the query. Now, without modifying this, keeping this intact, we would try to fix the query. Let's try to fix it on the notepad first. This can be now achieved in two ways. One of the way is either we comment out rest of the query, or we add some extra characters to balance the unbalanced quote. Let's try to achieve the first one. Try to just comment out the rest of the query. Comments can be provided in form of a double dash, or they can be provided in form of a hash or a pound sign, and they can be provided in form of a slash, star, and star slash. So MySQL accepts these three forms, but we are not directly interacting with the database. We are interacting with a web front end, and that front end is actually creating a query and trying to interact with the backend. So there are some constraints. So one of the constraints is that when we use double dashes to comment out rest of the query, then we need to provide an extra space after the double quotes. If we don't, it will not work. Let's try it. If we just provide double dashes and try to press enter again, the error is not gone. That means the comments did not work as intended. So let's try to give the space, but as we are working with the URL, so we have to encode it in the URL base, or let's say it should be URL encoded. %20 is used for space. As you see, we get the input back. So we were able to mend the query by commenting out the rest of the query without altering what we had used to break the query in the first place. We can also use the pound sign, but again, as this is an injection through the URL, so we have to URL encode the pound sign or the hash, and URL encode for this is %23. Again, the query works. Okay, so far so good, but the question comes to mind: why are we doing all this process, and what is the significance? Why do we need to first break the query, then why do we need to fix the query by adding something else? Well, the focus is like this. Let's go back to our notepad and let's copy this initial query, and let's remove these extra symbols. Okay, now if you see in real time, or if you try to think, the developer has already enclosed two quotes around whatever we input, and quotes are used to encapsulate or just mark the start and end of a string. In programming languages, whenever we are writing a string, we always use a single quotes or a double quotes to just put the string inside. And our focus to get the SQL injection is that whatever input we are giving, input in form of data, rather than just being interpreted as data, it should interpret as SQL code and it should give back the results. So when we give an extra quote here, we are actually closing the string, and then we have some space to write something else. By putting the comments, we clear out the rest of the part. So effectively we have a left side and a right side. Left side is 1 apostrophe and the right side is double dash, and we can use a plus sign. That is also equivalent for space. Once we find the left side and the right side and we have closed the string, anything we write after that will be evaluated as code, not as data. Let's try this out. As we see, 1 apostrophe, it breaks the query. Then we put double dash and a plus sign for space to fix the query. Okay, it works. Now we need to evaluate whether what we have thought of really works. How to do that? Let's use an operator and 1 equals 1. We have seen at many places that always when we are doing SQL injections or kind of things, we provide 1 equals 1, but our objective of providing 1 equal 1 is that when the query gets evaluated, 1 equal 1 means 1 or is true, or true in other sense again means 1. Confused? It will clear up, no problems. And let's check this out. Okay, we have this on the screen, and if we evaluate 1 equals to 0, that means this part is not true, or in other words false. Then the whole query becomes false. Let's try this out. Bingo. So what we anticipated, that anything we put in between the left side and the right side would be evaluated as code, it did. I hope you have understood till this part. The video is getting longer, so I would complete the rest of this lesson in the next video. Hope you enjoyed it. Please leave your feedbacks. Thank you very much. Bye.